Good afternoon, everybody. Just tell me if my voice and my video is visible to you guys or not. Please verify. Then we will start with today's concepts. All right. Thank you so much. Now let's begin. So today we will start with even and odd functions. Also, we'll try to cover in the same class as periodic function. So this even and odd function are the type of a function. See, if a function is such that it satisfies the property that fx is equals to f of minus x, means you replace x by minus x and that negative sign gets absorbed, then the function is called even function. Okay. So the even function, for example, like fx equals to x square, fx equals to cos x, fx equals to mod x, fx equals to 1 plus x raised to the power 4. They all are the examples of even functions. And I hope this is simple and quite clear to everybody. So even functions are the functions which absorb the minus sign if their x is replaced by minus x. Got it? So fx is equals to f of minus x. So these functions are called even functions. Am I clear? Now there comes odd functions. So if f of minus x is minus of fx, f of minus x is minus of fx, means if I replace x by minus x, it spill out that minus sign outside. For example, fx equals to x cube or sin x or tan x or x की power 1 by 5, they all are odd functions. Got it? So if f of minus x is minus of fx, the function is what we call even function. If f of minus x is minus of fx, the function is what we call odd function. All right. Now, one more very important point, it is not necessary. It is not necessary that every function has to be even or odd. There might be certain functions which are neither even nor odd. There are functions which are neither even nor odd. We'll go through their examples in a while. Now see, for this neither even nor odd, I'll use the word NENO. N-E-N-O. Now see the simple example. What they have given you, fx equals to a to the power x plus a to the power minus x. All right. If I replace x by minus x, what do you get? F of minus x is a to the power minus x plus a to the power x, which is again fx. Means it has absorbed its minus sign. So this is what? This is even function. Am I clear? Another simple example, if I see, fx is sine of x to the power 7, e to the power x to the power 5, signum of x to the power 9. Try it once. I give you 30 seconds to think of. Try it once. Tell me if it is even or odd or what it is. Okay, I got a response as odd. Anybody else? Now see, if I replace x by minus x, f of minus x will be sine of minus x raised to the power 7 e to the power minus x raised to the power 5 signum of minus x raised to the power 9. This is what? Sine of x to the power 7. This minus sign will come out. It is e to the power minus x to the power 5 minus of signum of x to the power 9. Because why I have done this? Whenever x is positive, signum x will be plus 1. But if x is negative, signum of x will be minus 2. So if this quantity, signum of x to the power 9 is positive, the signum of minus x to the power 9 is negative. So this minus and minus will become positive. So minus of sine of x to the power 7 e to the power x to the power 5 signum of x to the power 9, which is minus of fx. All right. So if that was even, sorry, so this fx is an odd function. Very good, Sridev. Very good, Rahul. Very good, Sunanda Kumari. Now, let's see a few more examples. See, fx equals to log 1 minus x upon 1 plus x. What do you have to say about this? See, if I replace x by minus x, I get f of minus x is log of, it will become 1 plus x upon 1 minus x. Isn't it? If I add both of them, then fx plus f of minus x is log 1 minus x upon 1 plus x plus log 1 plus x upon 1 minus x. And that is log 1, and log 1 comes 0. So it's quite clear that f of minus x is going to be minus of fx. Yes or no? So it became an odd function. Am I clear? Very simple example. Another example, if you see, fx equals to log under root of 1 plus x square plus x. All right, you try it once. I again give you 1 minute. Or very good. Even Nagashri, try again. Anybody else? See, it is an odd function. If I check f of minus x, it will be log under root of 1 plus x square minus x. Again, you add both of them. So fx plus f of minus x is log root of 1 plus x square plus x plus log root of 1 plus x square minus x. Now log a plus log b is log a into b. So it will become under root of 1 plus x square whole square minus x square. So that is log 1 plus x square minus x square. That is log 1, which is again 0. So again the same thing happened, that fx plus f of minus x is 0. This implies f of minus x is again minus of fx. So it became an odd function. All right. Simple example. Now, another question, if I ask you, fx is sin x plus cos x. Yes, tell me. Fx is sin x plus cos x. What it will be? Even, odd? Okay. Anybody else? Odd? I don't understand which method you guys are applying, that you are getting it as an even or odd. Tell me one thing. If I try to find f of minus x, it will be sine of minus x plus cos of minus x. Sine of minus x is minus sine x. Cos of minus x is cos x. Cos absorb its minus sign. Now, if you realize fx is not equal to f of minus x, also fx plus f of minus x is also not equal to 0. What did I tell you? It is not necessary that every function has to be even or odd. Few functions come into the category of neither even nor odd, and this is one of them. This function is neither an even function nor an odd function. All right. See another example. Fx is equals to x a raised to the power x plus 1 upon a raised to the power x minus 1. All right. Check once what it is, even or odd. Take 30 seconds quickly. All right, odd. See, f of minus x will be minus x a to the power minus x plus 1 upon a to the power minus x minus 1, isn't it? This can be written as minus x 1 upon a to the power x plus 1 upon 1 upon a to the power x minus 1. So minus x into 1 plus a to the power x upon 1 minus a to the power x. Yes or no? Take minus common from this bracket also. So it will become a to the power x plus 1 upon a to the power x minus 1, which is again fx. So your f of minus x came fx. So function is what? Even function. Got it? Mr. Suraj and Mr. Bhagat, think again. All right. Next, fx is 1 plus 2 to the power x whole square upon 2 to the power x. Check if it is even or odd. All right. Is it done? Even. Okay, I got 4 even. I assume everybody must be correct. Now see, fx equals to, if you replace x by minus x, it is 1 plus 2 to the power minus x whole square upon 2 to the power minus x. So it will become 1 plus 1 upon 2 to the power x whole square upon 2 to the power minus x. So if I take LCM, 2 to the power x plus 1 whole square upon 2 to the power x whole square into 2 to the power minus x. So in the denominator, 1 2 to the power x will get adjusted. So it is 2 to the power x plus 1 whole square upon 2 to the power x, which is again what? Fx. So since f of minus x is equals to fx, this is an even function. Very good, and round of applause for those who identified it. Got it? Now, another function fx is greatest integer x plus greatest integer of minus x. See, this is very simple to see. I'll do it on my own. F of minus x is going to be greatest integer minus x plus greatest integer x. Very simple, even function. Got it? Now there comes a jackpot question. Fx is x upon e to the power x minus 1 plus x by 2 plus 1. Tell me if it is even function or odd function. Try quickly. Bhuvan, odd, very good. Anybody else? JNV Kadapa, odd. Odd. See, those, everybody who is replying odd, I doubt if they have even solved it or not. See, what is f of minus x? F of minus x will be minus x upon e to the power minus x minus 1 minus x by 2 plus 1, isn't it? Now, this can be written as minus x upon 1 upon e to the power x minus 1 minus x by 2 plus 1. If I take LCM, it will become minus x e to the power x upon 1 minus e to the power x minus x by 2 plus 1. Adjust this negative sign, you get e to the power x minus 1 upon x e to, sorry. Adjust this negative sign, you get x e to the power x upon e to the power x minus 1 minus x by 2 plus 1. Now, if I subtract both of them, fx minus f of minus x. Fx is x upon e to the power x minus 1 plus x by 2 plus 1 minus f of minus x is x e ki power x upon e ki power x minus 1 minus x by 2 plus 1. Now from this and this, x minus x e to the power x upon e to the power x minus 1 plus x by 2 plus x by 2 and 1 cancel. Got it? Now if you take x common, you get 1 minus e to the power x upon e to the power x minus 1 plus x. Now if this cancel, it comes minus outside, so it is minus x plus x, which comes 0. So it becomes what? Even function. See again, see very carefully. Got it, guys? See, there is no particular criteria when we have to add both the functions, when we have to subtract both the functions. Got it? Like in previous question, I added both of them. I got fx plus f of minus x as 0. In this question, I subtracted both of them. So it is just a chance. What I realized, if I subtract both of them, this one will cancel. Because cancelling this one is necessary. Got it? So I did that. So it is just a matter of chance. And otherwise, this one won't cancel. I won't be able to justify between even and odd. So there is no particular criteria. Got it? Now, see, something about even and odd function, something really important. First point is what I have already told you. A function may be neither even nor odd. Like 1, 1, you know, every function has to be either 1, 1 or many 1. It is not like a function is neither 1, 1 nor many 1 or both 1, 1 or many 1. Got it? So, but here also even and odd may a function can be even, can be odd, can be neither even nor odd. Next, every even function is symmetric about y-axis. Very important point to remember. Every even function is symmetric about y-axis. And every odd function is symmetric about the origin. So every even function is symmetric about the y-axis and every odd function is symmetric about the origin. All right. Now, every function which has minus x in its domain, whenever x is in its domain also, definitely for a function to be even or odd, x and minus x both should be there in the domain. Got it? So if in a function, x and minus x both are in the domain. So any function can be expressed as the sum of even and odd function. Like in matrices you have studied, every matrix can be represented as the sum of a symmetric and a skew-symmetric matrix. Similarly here, every function can be expressed as the sum of an even function and an odd function. So how do we get it? If fx you have, which is even or odd or neither even nor odd, you do what? You multiply by 2, you divide by 2. Multiply by 2, divide by 2. Now in the numerator, after 2fx, you add f of minus x and subtract f of minus x. So numerator ko I can write ff plus f of minus x and fx minus f of minus x upon 2 upon 2. Am I clear? Now, this is what? This is the even part of fx. And this is what? This is the odd part of fx. Here, if you realize, this is the even part, even function, and this is going to be odd function. So every function can be expressed as the sum of an even function and an odd function. All right. Now, another very important point, fx equals to constant. And this constant not equal to 0. Fx equals to constant which is non-zero is an even function. But fx equals to 0 is considered as even as well as odd function. Fx equals to 0 is considered as even as well as odd function. Got it? So fx equals to constant is neither even nor odd function, but fx equals to 0 is considered as even as well as odd function. That is the only function, fx equals to 0. Now, if I ask you a function, fx equals to greatest integer of mod sin x upon 2. Tell me if it is even, it is odd, it is neither even nor odd, or what it is. Even, okay, Bhagat. Anybody else? Even, Bhuvan, even. See, we all are aware of that this sin x lies between -1 to 1. That means the sin x upon 2 lies between -1 by 2 to 1 by 2. That means mod of sin x upon 2 is less than or equals to 1 by 2 and definitely more than or equals to 0. So if this quantity mod sin x by 2 is lying between 0 to 1 by 2, that means greatest integer of mod sin x upon 2 is going to be 0. So the function is fx equals to 0. And if the function is fx equals to 0, it is considered as even as well as odd. Or it saying it only even is like bit of lack of knowledge, I would become say. Now, see, you have two functions fx and gx. If they both are odd, then their summation or difference is going to be an odd function. Their product is going to be an even function and their division is also going to be an even function. Simple thing to analyze. Got it? If fx is even, gx is also even. Their sum is going to be even, their difference is going to be even, their product is going to be even, their quotient is also going to be even. Got it? If one is odd, other is even, then the sum or difference is neither even nor odd. This is same as the category which I taught you, sin x plus cos x. Sin x is odd, cos x is even. So their summation which came is neither even nor odd. Their product is going to be odd, their quotient is also going to be odd. And same as the last one. All right. Now see, there is a simple question. Determine whether the given function hx is even or odd or neither of them. Tell me quickly. This hx is even or odd or what? Neither even nor odd, yes. H of minus x is what? Minus x cube minus x square minus 1. So it will become minus of x cube minus of x square minus 1. Finish. So neither even nor odd. You may realize this is odd, x cube, this is odd, and x square, this is even. So one even, one odd. So their summation will be what? Or difference will be neither even nor odd. Got it? Now, periodic function. Again, very important portion with respect to JE point of view. Periodic function. See, a function fx is said to be periodic function of x if there exists a positive real number t such that f of x plus t comes fx. Got it? This is important, such that f of x plus t comes fx. The smallest value of t is called fundamental period of function. The smallest value of t is called fundamental period of the function. Got it? Now, see, the graph of fx equals to sin x repeats after an interval of 2 pi. If you realize this is the graph of sin x. See, I give you another picture. This was a theoretical definition. Like f of x plus t comes fx, so period of the function is fx. Now, see, the graph of a function is something like this. Actually, I made the graph of sin x. Graph of a function is something like this. Now, if we can realize, if I can make a particular portion of the graph and I make a stamp out of it. Stamp means that postage stamp kind of. You make a stamp out of it and you keep on pasting it further. Are you going to get the entire graph in this case? Yes. So the length of this stamp, which is going to be 2 pi, is going to be the period of the function. Got it? I intentionally made fx equals to sin x. Got it? So this is the period of the function sin x. Got it? Now, the graph of fx equals to sin x repeats after an interval of 2 pi. Thus, fx equals to sin x is periodic function with a period of 2 pi. And this is what we can analyze from the graph also. As a homework, I am telling you, draw graphs of all 6 trigonometric functions. Got it? This is a responsibility I am going to give you. Draw the graphs of all 6 trigonometric functions. Check their domains, range, period. Got it? Remember all of them. Now see, few functions we will do. I'm going to write a function. and I'm going to write its period. There are not so many periodic functions in our content. We have a few periodic functions which can easily be remembered. See, first is sin x. Sin x is periodic with period 2 pi. Got it? Sin x is periodic with period 2 pi. Then there comes cos x. Cos x is again periodic with period 2 pi. Then there comes tan x. Tan x is periodic with a period of pi. If you draw all their graphs, you will realize it very soon. You can get their graphs in any book, but mark my words, remembering their graph is very necessary. They are going to be an asset for yourself in the coming classes. Then cot x, period is going to be again pi. Then cosec x, period is going to be 2 pi. And then secant x, period is again going to be 2 pi. Now there comes their modulus. Okay, one more function I would like to state here only. Fractional part of x. If you remember, we have drawn its graph also. Fractional part of x is periodic with period 1. Got it? Now there comes mod sin x. Periodic with period pi. What will happen in case of mod sin x? If this is sin x, mod sin x is going to be something like this. Like this. And I taught you in previous class, mod, what will mod do? That will copy the negative portion in the positive x-axis, positive y-axis. Then there comes mod cos x. Mod cos x is again periodic with period pi. Then there comes mod tan x. Its period is also pi. Then mod cot x. Its period is also pi. Then mod sec x. Its period is also pi. Mod of cosec x, period is also pi. So modulus of all 6 trigonometric functions is modulus of all 6 trigonometric functions is what? Pi. Got it? Now, few properties of modulus function. See, if I talk about sine to the power nx, cos to the power nx, sec to the power nx, cosec to the power nx. Got it? So period is going to be pi when n is even. Why pi? Because the below x-axis portion will also reach above x-axis. And if n is odd, period will remain 2 pi. Simple point, easy point. If n is even, like sine square x, sine to the power 4x, period will become pi. And if it is odd, that is sine cube x, sine to the power 5x, period will remain 2 pi. And in case of tan x and cot x, 10 to the power square, 10 square if I do, 10 cube I do, or cot square, cot cube, whatever do I do, period is going to be pi only. It will remain pi. Now, mod sin x, mod cos x, mod tan x, mod cot x, mod sec x, mod cosec x, mod of any function is going to be, period is going to be pi. Now, fraction part of x, period is going to be 1, which I already told you. Remember one thing, few students feel like greatest integer x is also periodic, which is not. Greatest integer x is repeating but not along the x-axis. It is going also along the y-axis. So it is not periodic. Got it? Now, if fx is periodic with period t, then k times f of cx plus d is periodic with period t upon mod c. Got it? Hence, the period is affected by the coefficient of x only. For example, if I talk about fx equals to sine 3x, what the period is going to be 2 pi upon 3. If I talk about fx is fractional part of 5x, what is the period of fraction part of x? 1. So period of fraction part of 5x is going to be 1 by 5. If I talk about fx is cos 2 pi x, period of fx is 2 pi. So fx cos 2 pi x is period is going to be 2 pi upon 2 pi, that is 1. Fx equals to mod of sine 5x. Now see, mod of sine x period is what? Pi. So mod of sine 5x period is going to be pi by 5. Got it? Now, next point. If fx has period t, then 1 by fx and root fx also have period t. If fx has a period t, then 1 by fx and root fx also have period t. Got it? Now, see one very important property. If fx has period t1 and gx has period t2, period of fx is t1 and that of gx is t2, then period of fx plus minus gx or fx into gx or fx upon gx is LCM of t1 and t2 provided their LCM exists. This is important, provided their LCM exists. However, that LCM, if exists, need not be the fundamental period. Getting my point? It is not necessary that LCM is the fundamental period. A fundamental period can be even less than that LCM. And if LCM does not exist, then their functions are called non-periodic or aperiodic. Like if you realize, one question I would like to ask you. See, fx equals to mod sine x. What is the period? Pi. Fx equals to mod cos x. What is the period? Pi. If I add both of them, I make a new function that is mod sine x plus mod cos x. Now see, its period is pi, its period is pi, but some period of their summation is going to be pi by 2. And why is it happening? Because they are converting into each other. After an interval of pi by 2, sine pi by 2 plus x will become cos x and cos pi by 2 plus x will become minus sine x, which minus is being absorbed by modulus. Got it? Now, say fx is sine square x plus cos square x. See, isn't it 1 directly? But if I see sine square x is periodic with period 2, pi, cos square x is periodic with period pi, but sine square x plus cos square x, if I talk about, it is periodic, but no fundamental period, defined. Basically, for every constant function, like fx equals to 2 or fx equals to 1, they are periodic, but their fundamental period is not defined because we cannot find the length of that frame which I taught you in the beginning of this periodic function. Got it? Now see this example. Fx equals to sine x. What is the period? 2 pi. Fx equals to fractional part of x. What is the period? 1. Now see, one of them is rational, one of them is irrational. 2 pi is irrational, 1 is rational or integer. 2 pi, the multiples of 2 pi will be 2 pi, 4 pi, 6 pi will all be rational. Multiples of 1 will be 1, 2, 3 will all be integers. So they will never have an LCM. So LCM does not exist. So function is aperiodic. Now sin x by 2. What is the period? 2 pi upon 1 by 2. That is 4 pi. Tan x by 4. Pi upon 1 by 4. That is also 4 pi. So overall period is going to be 4 pi. Now 25 times sin 6x. Period is going to be what? 2 pi upon 6. That is pi by 3. Got it? So this was all about periodic function. It's an important topic, important portion. Do go through it once again. It is going to help you a lot. It's a good question. Got it? Anyways, thank you so much for being in